Hello guys and welcome back to a new video. Today we are in Paris at Motor Show 2024 and I find here some battery manufacturers about CAVB, and I have with me my friend here. What is your name?
My name is Yang.
Yang.
Yeah.
Yang here will explain us about CAVB and what they do with the batteries. And I know you have so many questions about the battery because it comes this transition between fossil fuel cars to electric car, and probably the electric is the future. And I see that they improve all the time, year after year. Jan here will explain us a little bit more about battery. You will see the difference between LFP battery and NMC battery and what come in the future. So Jan, thank you very much for this time that you offer us to explain us about the battery. Can you tell me a few words about your company and history a little bit, and for what kind of customers you are open to sell and provide?
Thank you for having me. So our company is basically we design and manufacture of the battery.
Yeah.
So these batteries contain three things. The battery, the electrical performance, we call the battery technology, and also the battery integrations to make the battery systems. This is ready for use for the vehicles.
Yeah.
And the third point is the battery management system, how to monitor and control and diagnose the batteries. These are the three things we basically do to make the battery pack. Yeah.
Great. I see here in the front you have a few type of batteries, right? So there are these circular, or I don't know how they call it, like cylinder.
Cylindrical cell.
Yeah.
Yeah, so this one, we have the two different type of the cylinder cells. They all share the same diameter, the 4600 series. We have 4695, 46150. That is specifically for the BEV, the pure electrical vehicles.
Yeah.
They can do with a different voltage range. It's fully expandable.
Yeah.
So that's for the cylindrical cell we have. So besides this one, we also have we call the prismatic or square-shaped cell.
Yeah.
So in that cells, we have the different applications for the HEV for the hybrid.
Yeah.
And for the PHEV plug-in hybrid.
Yeah.
And also for the HEV for the
full hybrid, for electric.
Fully electric.
Yeah. And I saw that Tesla used this type of battery cylinder, right?
Yes.
And what, from your opinion, which one do you think it's better, or it's no such a word like better or worse?
So in terms of performance-wise, they serve roughly the similar performance.
Yeah.
But they do have the disadvantage and the advantage. For this prismatic one, because we have a lot of experience regarding the market share and also the R&D part.
Yeah.
So the volumetric efficiency is higher.
Here on this.
Because the battery pack is always a square shape.
Yeah,
it's a square shape, you can perfectly feed the X and Y directions.
Yeah.
And for the cylindrical one, and the benefits is that it's really for the security part, maybe it's easy to expand.
Yeah.
You can add more, much more easier in that case.
Yeah.
So both they share some sort of benefits. Yeah, they do have the pros and cons.
So do you think they think about expanding, and that's why they choose to use those maybe, or?
Yeah, so manufacturing process is a kind of difference.
Yeah.
But a lot of our product in the market, we're using the prismatic.
Yeah.
Yeah, for that.
So you think in the future will be some kind of this design, or you think this will be more used, right?
Because right now they have a higher market share for the prismatic. Yeah.
Okay, great. Now let's go a little bit in the back to explain me about the NMC and LFP battery and the differences between it. I see that you also, this is for the plug-in hybrid, right? This product hybrid here. So you also make the batteries, and then you build it together, like you give to the, let's say, to the producer or of the manufacturer of the car, you give the battery complete, right?
Yes.
Based on the plans that they give you, the numbers, the size, and
because the battery cell is too small. It cannot support the whole vehicle.
Yeah.
So in terms of energy, so in this case, we have to stack the cell like with a different amount of cell to ensure we have enough energy.
Yeah.
Make sure we have the longer range.
Yeah.
that
Okay.
purpose.
So
That's we call the system integration.
yeah.
Uh,
So
we,
and you kind of give the warranty to the manufacturer, something like that, or when you
we manufacture our own.
your own, yes,
Yeah,
and
yeah.
then you give to the
The OEM to our
OEM.
right.
Right, right.
Yeah, the car maker. Yeah.
Okay, but you make it completely and then you just give the battery completely made,
Yes,
right?
complete batteries and delivery.
Nice, nice, nice.
Uh,
And usually you give also the warranty for the batteries?
8 years.
8 years.
10 years, 15 years. Depends
Yeah.
on different requirements
Yeah,
of our client.
nice.
Yeah.
And what do you think when a battery is broke, you can recycle it, or what do you think about recycling the batteries?
Right now, we're working with a third party for the recycling.
Yeah.
So in terms of the cell, for the active materials, we can
Yeah.
go up to 90% of the even higher
Yeah,
can be recyclable.
Nice.
So yeah, I think
It's not.
because right now a lot of electric vehicles is on the market,
Yeah.
and recyclability is definitely the key
Yeah.
for our clients' focus. So,
But those can be repaired, or
yeah, some
if
parts
once-
definitely repair.
Yeah.
For example, for the module, we can just
Yeah.
replace the module with
Yeah.
a new one. And also for the BMS, in
Yeah.
terms they have some problem, we just open the cover and
Yeah.
put a new one in.
Yeah.
So it seems
Nice.
some of the parts can definitely be repaired.
Yeah. So you make here are the controllers, right? The management system.
Yeah, this is
Or-
our we'll say the second technique of our case, the battery management system.
Yeah.
So they have the two functions, like certain functions. The first, they need to monitor the battery status.
Yeah.
Like make sure everything is stay on track.
Yeah.
It's pretty safe.
Yeah.
In case we have some low voltage,
Yeah.
we always warning, oh, it's time to charge the battery.
Yeah.
So this is what we call the monitoring.
Yeah.
Also, they have some problem. For example, we have so many cells.
Yeah.
So for example, the one cell is very low capacity. We always do some adjustments.
Adjustments,
We call
yeah.
balancing.
Yeah.
So this is also the BMS can work. Also, in case we have some abnormal situations, like the safety events, they can always do some warning
Yeah.
to the passenger.
Uh-huh.
So there's also another.
So you
other
know,
case.
you get some errors or something like that, right?
Yes.
And for example, I saw on the LFP battery on the electric car, when you charge it to 100%, then it says calibration.
Yeah.
Well, this is the management system which calibrate the voltage in the battery,
Yes,
right?
Yes. Especially for the fully charged.
Yeah.
So they can do the recalculation to make sure the SOC can be read accurately.
Yeah,
So,
but this I have a question for you. Because many people are a little bit confused about the LFP battery because they usually, the car manufacturers like Tesla, for example, here they recommend to charge it once a week to 100%. And the question is, to 100%, it's good for the health of the battery to charge it to 100%, or LFP, I mean, about the LFP battery, or what do you think about that?
It's okay because LFP is very safe.
Yeah.
So in our case, there is we call the no thermal propagations occur.
Yeah.
So 100% is definitely you can definitely charge 100% without any. Even the overcharge is still very safe.
Yeah.
Compared to NCM.
Yeah.
But the lower one, so you cannot drain out the batteries. It's lower than like 3%.
Yeah.
The reason for that is because the tolerance of the management.
Yeah.
For example, the accuracy.
Yeah.
About 2 or 3% of the
Yeah.
SOC accuracy.
Ah,
So we're not sure. We don't want to the overdrain the battery because that's permanently influence the cycle life.
Ah,
So
okay.
that's why for the LFP we always like from 2 or 3% to 100%.
So you think it's worse to go lower than go higher?
Yes. Yes.
So what you recommend, to hold it over 10% or?
Because well, BMS can definitely set up a target.
Yeah.
So once you achieve 100%, it's not allow you to charge.
Ah, okay.
So we can set this boundary.
Ah,
by
okay.
using our software.
Yeah.
Yeah.
But I mean, if you charge it to 100%, like 3 times a week, the life cycle of the battery will degrade faster, or it doesn't matter on LFP battery?
It's okay because they have about 2,000, more than 2,000 cycle life.
Yeah.
They're beginning, they definitely they have some degradations.
Yeah.
But everything is about 80% SOH.
Yeah.
We think they should be fine.
Should be fine.
Yeah.
Okay.
Uh-huh.
So it's fine to charge it to 100% because it has a lot of cycles,
Yes,
and
yes.
it's better than NMC. But on NMC, what would you say?
MC we set target about 3% to 98.
Yeah.
So that's
98.
the only reason is that the safety, right?
Yeah.
We don't want to overcharge
Yeah.
to have the safety event. And 2% or 3%, that's the tolerance of the
Yeah.
FOC management from the software level.
Yeah. So you mean like if you have an electric car and you charge it to 100%, it's not 100%. It's just show you that it's 100%, but
Probably
it's
98, yeah,
probably 98.
for the NCM.
Ah, so they leave a little bit of space up
Right,
and
right.
down the same, right?
Down is the same. Right.
Because I saw some people drive the electric cars with 0% battery. They still drive around
so.
20 kilometers or even more.
But in this case, I mean, from the software level, it does not allow you to drive.
Ah, really?
Cut off the volume,
Really?
the current,
Really?
the
So
power, right?
so you mean like even if you try to drive more,
Uh-huh.
the car will stop, but the battery will still have some battery for safety reason, right?
Right.
Man, that's good. That's good one. That's smart. I didn't know that.
That's why the software works,
Yeah.
always in control to make
Ah,
sure
so-
everything is safe.
Yeah, so to be safe with the battery, to keep the battery for, yeah, this is smart system. So all this, this is like the computer to control everything, including the cooling.
The coolant, and also the contactor.
Yeah, the
So
contact.
you cannot open the battery. You cannot let the contactor on. So they have to do some like preliminary work
Yeah.
for the BMS. Yeah.
Okay, great, great.
Yeah.
Let's go forward. Here you have like, you said before, like you have some storage.
Integer storage systems. In our case, we have. So this is for the larger storage systems.
Yeah,
We're using the lithium ion phosphate cell.
yeah.
They have, so
Yeah.
the one blinking one actually is for the coolant,
The
liquid
coolant
on
to
the bottom.
cool the, yeah.
right? To cool down.
So this usually it's huge system
Right.
for the buildings, for companies, for, yeah, different use
Yeah,
scenarios.
For the
So you
larger-
build this completely and you deliver to the clients, right?
That's right.
Nice.
Uh-huh.
And also it used the LFP battery, I see, because they have a longer life.
Cycle life and more secure.
It's more secure, yeah, in
and
case
more
of one.
price affordable. So
And it's exactly just that it's more heavy, right?
yes, yes,
And
that's right.
nice. Okay, great. Let's go to the fun part.
Sure.
Here you said to me before, like you have this one here, it's like the battery for the trucks, right?
For the trucks, yeah.
And the question is, because I saw there, the battery for the trucks, they have different type of chemistry, or they are heavy duty or something like that. I don't know.
Yeah, this
So
one
they have,
it's very huge. About 500 kilos, more than
Yeah.
500 kilos.
yeah,
Typically for the heavy duty truck, we have the four
Yeah.
kind of module and to make a stack.
how big is this? 100 kilowatts or
About 87.
87? Ah,
right.
okay.
87, but at least four about 300 more than like
Yeah.
kilowatt.
And this is not the, it's NMC or LFP battery?
LFP.
Yeah.
This is all the LFP batteries.
Okay.
They also have the coolant inside.
Yeah.
Using the cell to pack.
Yeah. Yeah.
Yeah.
And I have another question. For example, you see on the cars, in case of an accident, right? If you hit something from lower in the battery, how strong is the case usually for the batteries?
We call the European standard, also the Chinese standard.
Yeah.
We call the bottom impact test.
Yeah.
So we did before we do the design, we always do the simulations.
Yeah.
So we set up the parameters, we ensure everything is good. That's
Yeah.
the first thing. So once everything is approved by simulations, we're going to make the part
Yeah.
and then do the real testing
Yeah.
in the battery level and
Yeah.
also in the system level.
Yeah.
So we
It-
definitely have different stacks.
Yeah.
in terms
Okay.
of the Chinese market and also the European market, also American markets.
Yeah.
And actually, we also So without parts, we cannot make the product. So
Right. So you sell also in Europe and
it's not only
all
on
of
the bottom, but also sideway,
Sideway,
even from the top, because
Yeah.
we have some passenger seat on the top.
yeah.
So we do
So-
sort of the validations. This is one of the actually development approach.
Yeah.
So, yeah.
Okay. Let's go to the other part. So that here you have the NMC on the upper side and LFP on the lower side. And you said before, like, we know already, or most of us we know already, that the NMC have a better high density energy, and the LFP they have more cycles and they are safer, right?
Yeah, pretty safe, and
Yeah.
also the cost will be lower.
Cost, yeah,
Cost will be
of
lower.
production.
That's why we have the economic. We call the economical
Yeah.
LFP cell
Yeah.
for the A segment or B segment vehicles.
Yeah. What would you say about recyclability? Which one is more recyclable? Like,
So right now, they roughly the same range. I would say for the LFP, for the cathode material, they
Yeah.
can go up to 98%.
90, yeah,
NCM probably 95, 96. That's
Yeah.
for the active materials.
yeah,
Because for the cell can, they can definitely 100%
Yeah,
recycle
yeah.
all the metal part,
Yeah,
copper,
yeah.
aluminum.
yeah.
So we don't have any concern regarding recyclabilities.
Usually an LFP battery, it has how many cycles? Like,
Around more than 2,000.
2,000.
So current status.
Yeah,
Before I
and-
think back to 2 years ago, about 1,800. So
yeah. And after 2,000 cycles, or what happened with the battery? It's just use less energy, right? It's
yeah, about
degrade.
80% isolation we call it.
80%.
So, for example, if we deliver this battery for 100 kilowatt hour, after about 2,000 cycles, then probably only about 80 kilowatt hours. So,
Yeah.
so in that case, we are not recommended to use these batteries on the vehicles.
Yeah,
So we probably will use it for the other application, for the energy storage system.
yeah, I saw that.
And make sure there is no harm on the safety.
If you would buy a car tomorrow, which type of battery would you get on your car?
Well, if I just graduate from the school and I don't have, I cannot afford the high price of fancy car, the LFP,
Yeah.
the better choice. If you really want to have the longer range,
Yeah.
and also the power, the high power,
Yeah.
NCM will be my
NCM,
choice.
right?
Yeah.
Okay.
Uh-huh.
But the LFP is safer
It is safer.
in case
Yeah.
of
Yeah.
an accident or in case of something happen.
A little bit higher.
Yeah.
So
Yeah. So it's kind of a balance between power and range and
Good.
good. Now I want you to tell me a little bit about the future of battery. What do you think will come next?
So there is I would say there is two things. And the first one, we want to increase the energy density
Yeah.
of the batteries. So right now, it's mentioned before, for the LFP, it can go up to 195,
Yeah.
and NCM about 250, and the solid state they can definitely go to much higher.
Yeah. Do you think the solid state is the future of the battery, or?
Yeah, definitely the extraction of the batteries to improve the performance,
Yeah.
performance-wise.
How?
Also make the batteries much more safer,
Yeah.
because all the E1 or the safety E1 will coming
Yeah.
from the burning of the electrolyte.
Yeah.
So using liquid, they can cause some fire explosion.
Yeah.
With the solid, safety can be
Yeah.
100% guaranteed. So,
So the solid state battery are the same safe as the LFP, will be the same safe or at the
even
LFP?
even safer.
Even safer, really?
LFP, right.
So the
Because there's no liquid
it's
inside
no,
the
yeah,
battery.
yeah. So it's no
So
fire or
anything-
something.
Yeah, fire.
Ah, nice.
Right.
So the solid state will be more safe than an LFP.
Right.
Will be more dense,
More dense, yes.
more than double, or
It's yeah.
more than
The
double.
double, right.
So that means if you have a car that drive 500 kilometer now with solid state, will drive 1,500,
Yeah.
right?
The same amount of battery. Yeah.
Same amount of battery and weight. It's incredible, right?
Yeah, that would be our target, but the current status is it's not the mass production yet. You can only
Yeah.
make a very small one. You cannot make a
Yeah.
high
But
capacity.
in how many years do you think will be this a reality and we will see it on the cars?
target is that because right now we are doing the pre-A sample phase.
Yeah.
We are going to build the prototyping line. I mean, for the
Yeah.
small scale.
Yeah.
In 2025.
Yeah.
And our goal is 2 years later.
Yeah.
2027.
Yeah.
We want this product is in
be
the mass production.
Nice.
So that's will be
So-
a lot of challenging.
Yeah. But 2030 probably will be already here on the market, and
Yeah. Hopefully
can-
2030.
I think will be a game changer to see a car over 1,000 kilometers for sure to drive. Like 1,500, it's already a dream. Like
There is no range anxiety for the passengers.
Yeah.
You don't have to charge the car a lot of times.
Yeah.
Uh-huh.
Yeah, but also the solid state, from the charging point of view, how fast it is. Like if you compare it with those two.
Yeah, so solid state is not as fast as our super fast charging product.
Yeah.
But it's 30 minutes from 10 to 80% SOC. So that's the current state. And the other drawback for the solid state is the energy density, so even lower than the LFP.
Really?
Uh-huh.
Oh, I didn't know that.
Yeah, but they do have some advantage. For example, the cold performance.
Yeah.
Like, when the temperature becomes lower,
Yeah.
the energy or the capacity will be lower. So in this case,
Yeah.
the sodium, they can still maintain about 90%
Yeah.
at minus 20 degrees C. That's one of the benefits.
Yeah.
And the second will be the cost, I would say.
The cost will be less, the cost for the solid state, really. So,
Nice.
yeah, because now I know the LFP battery, usually in cold weather, they perform worse than NMC anyway.
Right.
And solid state, you say you will be better, like
Definitely better.
Better.
Even better than the
the
NCM.
really, wow. So they have some advantage and disadvantage. Nice.
Uh-huh.
So another thing that I want you to tell me, it's like I saw here, and I know many people have plug-in hybrids or full hybrid cars, and I saw that you have those batteries special for, or where was here, right? Those are for the full hybrid system, 48 volt hybrid system, right?
Yeah.
I see,
We
like-
have 48 volt systems.
Yeah, in some, yeah.
Yeah.
But I saw that here it says like 35,000 cycle. Man, this is crazy, right? So tell me a few things about them. You said like it's not from 0 to 100, right? It's like
For the usable, we call the DOD, the depth of discharge.
Yeah.
So we can set up from like 30 to 80. That's normally used.
Yeah.
Because the purpose for this cell is to provide the power of the vehicles.
Yeah.
Or accelerate the vehicles. That's
Right,
the
right.
purpose. So you cannot go to the lower SOC, otherwise you cannot do their job. That's the first
Yeah.
thing. The second thing is I think only part of the reason is the more important reasons is that we did a lot of modifications
Yeah.
for the materials level and the process level.
Yeah.
We ensure the dynamic or the cycle life can be guaranteed by modifying the materials and the
Yeah.
interface. So this type of things, we did some work.
Yeah. So usually the idea is like that. Because I saw most of the full hybrid cars, they keep the battery automatically by the management system between somewhere 20, 30, like you say, and 80%, right?
Right.
This is something controlled by the computer, right?
Yes.
So in order to keep the voltage stable, or maybe to prolong the life of the battery, or this is the reason?
Yeah. So also we have the cranking, co-cranking.
Yeah.
Because this is also the function of this part of battery.
Yeah.
So in terms of the very low temperature,
Yeah.
so I also we can start the car.
Okay,
So
right.
In that case,
Right.
this battery, they can do their job.
Yeah, right.
If
So
it's
you
lower
need-
than like 30%,
Yeah.
no, it's
Pro-
not possible.
Okay, great. That's smart.
Yeah.
Plus, that mean the full hybrid batteries and plug-in hybrid batteries and mild hybrid batteries from mild hybrid system, they will last longer than the battery from a full electric car, right?
Yes.
So you can expect if you have an electric car to, let's say, have a lifespan of the battery of how long? If for example, I buy a car with LFP battery, how many years I should expect that the car will last?
Yeah, for the battery, we have the 10-year warranty.
Yeah.
So within 10 years, we should have do their job. So that's
Yeah,
for
yeah.
that one. for the hybrid, so that's the warranty. Actually the similar range for the pure electric. But as long as the gasoline or all the parts can be maintained, and the battery should be work as it is.
Yeah, but as an average, what do you think? For example, do you think a car with an LFP battery can last for 500,000, 50,000 kilometers, or 1 million kilometers? Because I heard online that people says that it's possible with an LFP battery that a car to make 500,000 kilometers or 1 million kilometers.
Yeah. Theoretically, actually, for the LFP, definitely it's longer than the NCM.
Yeah.
It's only the material performance wise, and also their own characteristic.
Yeah.
So so from the design, because the input from OEM says we have the 10 years and 30,000 kilometers.
Yeah.
That's our design boundaries, the minimum boundaries.
Yeah.
In that case, it should be over for that. Yeah.
But do you think it's possible, right? So that's the
LFP, yes.
Nice. So those have around 2,500 cycles or 2,500 around there. So nice. Thank you.
Yeah.
I don't know. You want to add something that maybe we didn't talk about, or something interesting about battery, or to say something that people maybe don't understand about batteries or about?
Yeah, so I think to sum it up, we basically do the three things. How we can make sure so the batteries in terms of electrochemical performance can do their job.
Yeah.
So that's all the cells to do. They can do the charging, discharging, and provide the performance of the vehicles. That's one part.
Yeah.
And the second part, and how we can integrate the cell in much safer way. For example, the mechanical performance, the impact, and also the environmental, the corrosion, this sort of stuff. And so that's the second one. And the last one, I would say, how to make sure the battery, the cell can do their job.
Yeah.
So we don't add a lot of extra parts, because in that case, it can waste some energies when the driving. And the last but not least, for the battery management systems, we always need to monitor, make sure everything is stay in the safe range. And in case we have some bad thing happens, we do some countermeasure. So we are the company to design and also to manufacture this battery pack. So we also have a lot of R&D to serve. So if you have any questions, and feel free to.
Thanks. But if someone wanna contact you to buy batteries, some company, where should they find you? You have a website or?
Yeah, we have the website. It's www.sevb.com. It's our
sevb.com, right? Okay, sevb.com. I will add it in the description of the video so people can see your work, and if they want to contact you, they can contact you. Thank you for your time. What one advice for the people that want to buy an electric car? Would you advise people to buy electric cars? Or what advice you have also for the people that already have an electric car? How to take care of the battery, how to take care of the battery in their cars, to last longer.
So so by the electric vehicle car. So basically, you have two options. The one is the NCM, one is the LFP. The one with the LFP batteries, so you make sure you can fully charge, because once you charge 100%, they do the recalculations. The software can know exactly the status of the batteries. That's good for the monitoring the batteries. I would say I would recommend to get fully charged. NCM one, you don't have to worry about. So you just make sure it's all in the safety range. It's very cold one. It's very cold weather. It still have some degradation, I would say. So cold weather, you have to be a little bit careful about the driving range. It's much about 50 to 60% driving range. Mainly is why you don't have
to think too much about right.
To change the gasoline, change anything else.
Because the people, they always ask, how much should I charge? How much should I go under? You have a recommendation like 10 to 90, 10 to 80 or something like that?
Yeah, LFP, keep in mind, always get a 100% charge.
Yeah,
It's
okay.
not harmful for the batteries.
Okay.
It's good for the batteries.
And under?
Under, well, if it's lower than the 20%, you have to find a way
Yeah.
charger station to charge it.
Okay,
because
so
we don't want to join out all the batteries because
Yeah.
it's a kind of permanent damage the batteries. So,
Okay, so
yeah.
not under 20%, so better
Right,
keep
right,
over
right. Keep it
20%.
about, that
Yeah.
would be great.
And an NMC?
The AMC one, so it's not recommended to get a fully charged
Yeah,
because fully charged is can definitely have potential risk in terms of safety. But the software level right now, they can set the
look a little bit.
the limits. So
Yeah.
even though you charge 100%, probably that's not
Probably,
exactly 100% battery.
Yeah.
So that I don't think there's going to be
Yeah,
a
yeah.
big concern.
Yeah, so you say from the terms, from the point of view of safety, it's not good
Yeah.
also.
Right.
And also degradation and safety reason.
Yeah.
So until 90% or what did you say, 90% or 80%?
80%.
80%. Okay, as a warranty.
age.
And under?
The state of the house.
Yeah.
Right.
And under?
And there is not recommended to use anymore. So
No, I mean under how much they can go, 10% or not under 10 or not under 20%?
yeah, so if you under like 20 or 10%, still recommend to charge
Yeah,
because
Yeah.
this is a charge you have charging at home is fine.
yeah,
If you have to go to the charging station, they always have some distance.
yeah.
So, yeah.
Nice, okay.
But driving experience very nice for the electrical vehicles.
Yeah,
Especially for the acceleratings,
Yeah.
very fast. I think very convenient. I think very beginning one, maybe passenger, you have to get use it
yeah,
because compared to the internal combustion engine, they always a very less time to
Yeah.
accelerate. So,
Yeah.
so that's one of the
right. So do you think the future is electric, right? With the car and auto industry?
yeah.
Do you think that for sure now?
Yes.
And in terms of progression of the battery, you feel like in the last year or in the future, the progression of the battery technology, it's growing, or you feel like we going on the right direction to improve the battery and all that stuff?
Yeah, I think back to the 2 years ago, you see the driving range will be increased. That's due to the development of the materials
Yeah.
and also the process.
Yeah.
Also the charging speed.
Yeah.
You can limit like 1 hour. So right now they can go 10 minutes. You can charge
Yeah.
the car
Right.
70% SOC. So
Yeah.
we are still working on to ensure all these batteries is serve the people's need. It's not give a lot of anxiety in terms of range.
Yeah.
So that's the first thing. I still think I still have a lot of chance to do the parallel. Like the one direction is still the internal combustion engine, but
Yeah.
with a hybrid batteries.
Yeah.
So meaning that the fuel efficiency is increased.
Yeah.
The second direction is this is the pure electrical vehicles.
Yeah.
So once maybe we have the solid state and the
then-
density can be further increased, so
Yeah.
we don't have to worry about the range anxiety. So
Yeah.
in that case, we can definitely adapt
Yeah.
all the electrical vehicles.
Yeah, right. And I think with a solid state battery will be also better for the trucks or big cars like buses, trucks or
Yeah, right now they're doing the lightweight maybe for the airplane.
really, yeah, that I want to ask you, but I think it's too big step to ask you about the airplanes. But do you think will be possible in the
So
future?
right now they can do the airplane.
Really?
Already have the airplane with the batteries inside.
Yeah,
So I think that's the one of the applications.
Yeah.
For the pouch cell,
yeah,
very lightweight. They can pack energy density one. In
nice,
that case.
nice. That's interesting to see.
Right.
Okay,
Right.
thank you very
Yeah,
much.
thank
for
you.
all. The link will be in the description, guys.
Uh-huh.
I hope the video was useful. Thank you for watching. Don't forget to like, share, subscribe, and I see you soon in the next one.
Thank you.
Bye,
Peace.
guys.
Cheers.